Hi guys, welcome to my session on AWS, and in today's session we are going to look at VPC scenario 2. So this video is a continuation to the previous video on VPC where we saw VPC scenario 1, which is something like we created a VPC, created a public subnet, and then we launched an instance in our own VPC. That's what we did in previous video, and in today's video we are going to see this scenario 2. And here let me show you what are the components in VPC scenario 2. So AWS VPC scenarios. So in total we have 4 scenarios, and in that we are going to see just first and second, and we have already seen first. We are going to see our second scenario today. Okay, let me open the pages. Right, so VPC scenario 2, VPC with public subnet and private subnet, and it will have NAT as well. Let me click on that. Let me go down for the architecture picture. Yeah, here it is. Right, this is what we are going to create today. Like it is in AWS, we are going to create our own VPC, and in that VPC we are going to create 2 subnets. One is public subnet and there is private subnet. So for people who doesn't have idea on subnets, so it is like when a subnet is connected to an internet gateway, then it is called your public subnet. When it is not connected to an internet gateway, it is called your private subnet. Okay, and what is a subnet? So subnet are nothing but a group of IP address or a range of IP address within our own network, within our VPC. In this case, we have 2 range of IP addresses. One is public subnet and another is private. So as I said, public is connected to internet gateway, whereas private is not connected to internet gateway. It has a different thing called a NAT gateway. And just a brief on NAT gateway. NAT gateway is something like an port opened, or it is can be an instance also, a NAT instance which is running in public subnet. So it is taken as a special instance via which the instances in private subnet will be connected to get the network updates or software updates and patches, and it will be using it for upgradation activities. So it is a special instance. You can take it in that sense. In our demo, we will be using a NAT instance and not NAT gateway, because in free tier NAT gateway is chargeable and NAT instance is not chargeable when we are using T2 micro instance. Anyway, not a big deal. Don't focus much on these things. Anyway, we'll be seeing the demo. At that time you will be getting it clarified. Fine. So this is the overview of scenario 2, and let me get into the demo so that it will be easy for you to understand. So I'm just logging in. Yeah, here it is. Right, this is our home page, and to go to VPC, go to networking and content delivery. In that, the first service is VPC, which is virtual private cloud. Click on that. Right, let it come up. So you will see the dashboard here, which is for VPC. We already have a VPC, which is nothing but our default VPC, and we have 6 subnets, which are nothing but the 6 availability zones. And normally it shouldn't be said in that scenario. We have to say like one network, one VPC is having 6 subnets, and each and every subnet is running in different availability zone in North Virginia. So North Virginia has 6 availability zones, so we have 6 subnets. And this is our default VPC, and we have already broke down this into each and every component, and we have analyzed that in the last video. So I'm just straight away going with our scenario 2. So this time in scenario 2, we are not going to build each and every component. Oh, we missed that page. AWS VPC scenarios. So we are not going to build each and every component here, something like what we did in scenario 1. So for scenario 1, we did something like we created our VPC first step, then we created our public subnet, then we created our internet gateway, then we attached the internet gateway to the VPC, then we made some entries in the route table of our public subnet. So we did step by step That's how we created the VPC scenario 1. Whereas scenario 2, we are not going to do in that manner because we have something very easy way to do the same thing. I'm going to the dashboard. In the dashboard, you see launch VPC wizard. Just click on that. Right, you land in this page where we will see all four scenarios: VPC with single public subnet, VPC with public and private subnet, VPC with public and private subnet with VPN access, then a VPC with private subnet only with VPN access. Right, so all four scenarios listed here. In this case, I'm going to select scenario 2. Click on this and click on select. Right. So this is a single page to create whatever components we have seen in scenario 2. This is a single page to create the entire stuff whatever displayed in this diagram. Right. So what are the things we are going to look at now? We have to give the range for VPC, range for subnet 1, which is public subnet, range for private subnet. That's it. And you have to configure your NAT details. That's it. Once you do this, everything will be set up for you on your behalf, and we just need to launch our instances in our subnet. That's it. So you will be really wondering how come these things happen, because for scenario 1 we did everything in a hard way. Once you see this, you see that you feel that scenario 1 was in a hard way. But anyway, let's look at it. Before that, I will show you that we don't have any instances running in our account. Go to EC2, click on instances. So no instances running in my account. I'm just making it sure. Right, let me go back. Okay, here it is. Let me open a notepad. So VPC, what range can we have? So I will go for some fancy ranges, and this is not as per the networking standard, because nowhere they will have a private IP like this. So I will just have it as 60. Right, so this IP range, I'm just taking it for demo purpose. So I'm just reiterating, this is not as per standard. Nowhere you will be seeing a private IP range like this, but I'm just taking it for our demo. So if it is /16, as per CIDR notation, we will get a 65,536 IPs. So I believe you people are very much comfortable in identifying these IP addresses and calculating the number of IPs for that particular range. And let me go for public subnet. So I will take one range here. So 0.0/24. So if it is /24, all 24 bits constant, only this can range from 0 to 255. So in total, I'll get 256 IPs for public subnet. And for private subnet, I will take it as the same thing but the different series /24. So these 24 bits constant, the last thing can vary from 0 to 255. So I'll get 256 IPs. Okay, cool. So this is what I'm going to place there. So I'll just copy the VPC range, and okay, before that I need to give a name for this. Oh, sorry. Here, copy the VPC range. Find name for this, VPC scenario 2. I'm just giving the name like this. So it is giving you a warning because this range and this range are not compatible. Anyway, we'll change this as per whatever we have decided here. Copying it, paste it here. So you can select any of your availability zone. Right, so if you leave it blank, Amazon will take it in random. And you see here 65,536 IPs. Amazon took 5 IP address for their own use, and here out of 256 IPs, Amazon took 5 IPs for their own use, and you have 251 IPs here. Fine, so I believe you people are clear with this. Then we go with private IPs. Again, you will get 256 IPs, and in that 5 IPs will be used by Amazon. Yeah, That's it with our VPC range, public subnet range and private subnet range. The next thing what you have to select is the internet gateway or the NAT gateway here. It's not internet gateway, sorry, it's NAT gateway. And when you are using NAT gateway, you have to pay for it. Whereas we are going to use NAT instance. Click on NAT instance. And by default, T2 Nano would have been selected. Just select T2 Micro. As you remember, T2 Micro is coming at a free tier and you can use it for 750 hours for a month. So you have to select T2 Micro, else if you are selecting anything like T2, even T2 Nano will charge you, right? So you can enable DNS host name, tenancy is default. You can go for dedicated also, but that will be charged for you. So I'm just selecting default. That's it. So I'm just showing you again. We didn't do anything here other than giving the ranges for VPC, public subnet and private subnet. And we selected T2 micro instance as our NAT instance. That's it. I'm just clicking on create VPC. Hope everything goes fine. Sometimes you may be getting an error in creating a VPC via Wizard, but don't worry. If you are getting an error, go to your VPC page. Whatever a partially created VPC will be displayed there. First delete that and then recreate it. Sometimes you get some issues. Even for me, I get some issues while creating VPC scenario too, but it's not a big deal. It happens normally. Right. So once I cross this step, everything would be fine. So this is, yeah, we are good to go. So this process will create everything for me. See, your VPC has been successfully created. Click on OK. You see our VPC got created with our CADR range, whatever we have specified. And in the meantime, I will show you the instance as well. Refresh it. You will see our NAT instance running. See here, T2 micro NAT instance. It would be in the private IP range. You look here, the same subnet, whatever we have selected. I said your NAT instance will be launched in public subnet. So this is our range. So the IP address will range from 100.100.0.0 to 100.100.0.255. So you see the IP address. Let me put it here as well. So it will be easy for you to 100.100.0.255. And similarly here 1.255 when it is /24. You see the NAT instance will be in this range 0.116. Yeah, that's it. So you go, let me go back to the VPC page. VPC has been created. Go to subnets. You see two subnets and you see an IP address list here because already a NAT has been launched. So you will lose an IP in public subnet. Private subnet is there. You have 251 IPs. Go to route table. You have the first route table. Routes. Internet gateway has been attached to our public subnet route table. Let me go to private subnet route table. You see an ENI entry here. So don't worry, it is nothing but go to your EC2 instance, NAT instance that is. You will see a network interface. Click on that. ENI 05D0C. Let me go back. ENI 05D0C7, the same ENI, which means you are linking your route table with your NAT entry. So let me go to the scenario page diagram. See, public subnet has to be linked with internet gateway, whereas private subnet has to be linked with NAT gateway or NAT instance. So in this case, since we use NAT instance, it has been linked with our ENI. So that is also done. Go to internet gateways. You see internet gateway created for VPC scenario 2 and it has been attached as well. So we didn't do anything here. Everything has been done on our behalf and we are good to go in our launching our instance. So many may be asking me the question, so can I do scenario 1 also in the same way? Yes, you are good, very well go with the same thing in VPC wizard, but once you do it manually, you will get to know a lot of things. You will get to know what issues you are making, So like, it will make you better in understanding things in VPC. If you go by a wizard, everything will be done on your behalf. You will not know what is happening in the background. If you do some mistake, then learn from it. It will be like it will be sticking to your mind. As far as I'm concerned, if you're good with the wizard, you can go with scenario one also in the same way. Right. I'm just going back to EC2 instances. Now let me name this as NAT instance, just for our understanding. Just naming it as NAT instance. Now let me launch an instance. Let me launch Amazon Linux, T2 Micro, configure instance details, and this time I'm going to select my scenario 2, similar to last time. But here we have two subnets, one is public, second is private. So I'm going to launch one instance in public, one instance in private. So I'm just clicking on public subnet, and remember, don't forget to enable public IP. Enable public IP. Right, so why I'm launching an instance? Go to the scenario, see, you can launch your web servers here and launch your database servers here. Okay, many ask this question as well. What do I need to launch an instance in public subnet? Why to launch in private subnet? Or you can ask in this way as well. What kind of instances can be launched in private subnet? What kind of instances can be launched in public subnet? So when you want to have your web servers where everyone need to have access over internet, it is something like you can go for public subnet. So want to access via internet. See, public subnets are the one which has been linked with your internet gateway, whereas private subnets are not. So you want to protect some instances like database servers. You don't want public to access your database servers from outside. So you should be protecting your database servers. In that case, you will go for private subnet. And NAT gateway is used only to get updates and patches for these database servers and not to connect from outside. So that is one thing which I have to say. Right. So I'm going back, enable the public IP for your public instance, add storage, add tags, give a name as public instance, configure security group. I believe you remember this. You will not see any of the existing security group because all our existing security groups were part of default VPC. This is a new VPC, so you will not see any security group here. So I'm just creating a new one. So I'll just name it as scenario 2 public security group. Instead, so I'm just opening port number 22 as of now. If I need any other ports, I can open it later. Review and launch your instance. Keypads will be available as they are not linked with our VPC. It is in common, I can reuse it. Yeah, good with our public instance in public subnet. Click on your public instance. You can check your private IP. Yeah, 100.100.0.32. 100.100.0.32 is within our range. So when you check in our subnets, you will lose one more IP in your public subnet. 249. Your private subnet is intact. So now what I'm going to do is I'm going to launch another instance. Again Linux, T2 Micro, and this time VPC scenario 2, instead of public, I'm going to launch it in private subnet. Right, now many ask this question on public IP. Do I need to enable public IP? In this case, see, private subnet is for creating your database servers. So you don't want to create public IPs because you don't want people to access something from internet. You don't want to access these kind of private databases from outside. You want to protect these databases. So in this case, you shouldn't enable public IP. Even if you enable public IP also, people won't be able to access this instance because in your configuration you are linking this private subnet with NAT gateway and not internet gateway. So these systems will not be directly accessible over internet via NAT gateway. So in that case, even if you enable, even if you enable public IP, you will not be able to access it from outside. Next, go to add storage. Click on add tags. Let me name it as private instance. Configure security group. This time you will have your public security group already available, but I'm creating a new security group because this is in private subnet, and obviously I'm creating this for a different purpose. Like let's take that if it is a database server, I have to open database port. So obviously web server and database server will have two different firewalls. So and I'll be opening database. If it is Oracle, I have to open 1521. If it is MySQL, I need to open 3306. So based on your database, you have to open a different port. So I'm creating two different security groups, one for public and this one is for private. Review and launch it. I can have the same key pair, doesn't matter. Launch instances. In real time, you can have different key pairs for developments or web servers and database servers, doesn't matter. Okay, cool. So we are good with our instances, one private, one public and one NAT instance, which is also running in public subnet. So when you launch your private instance, you can check your private IP. See, it is in 100.100.1.118, which is within our range. We are good with this. We don't have public IP. Since we didn't enable public IP, we didn't get it. Right. Okay. Now let's get into the system. Let's see how to get into our public instance and how to get into the private instance. Okay. So again, I'm going back to the architecture diagram. We know that web servers have public IPs and it is connected to internet gateway. So we can use PuTTY to connect to these instances. Whereas database servers doesn't have public IP and they are not connected to internet gateway as well. So in that case, you cannot connect to database servers from outside the network like using PuTTY or something. In that case, how to connect to it? So we know that anything within the VPC is local. See this? Anything within the VPC is local. Anything within the VPC is local. So to connect to database servers, first what you need to do is you have to connect to these servers via PuTTY using the public IP. Then from these servers, you can connect to database servers using your private IP. Since you are in the own network, local traffic is allowed. So within the network, you can connect from one instance to another instance. You don't need public IP there. So that's what we are going to do in this demo. So I'm just going with the demo. So we are good with the instances. I'm just connecting to the public instance, which is very similar to whatever we did in our EC2 demo in our scenario 1. So it's not a big deal. So it will be a recap for you people. Copy the public IP. Go to PuTTY. The public IP address. SSH. Authenticate. Select your key pair. PPK. And let me change this font so that it is legibly visible to you. Bold. Okay, I'm just opening it. Yes. Easy to user. Cool. So we are into the public instance. We are connecting to it, which means it has internet, or you can just ping some website and confirm it. Yeah, we are good with this. So this system is having internet connectivity, and we are connected to the public instance as well. So you can check the IP address, which is the private IP. Right? Now the challenge is how to get into the private instance. That is our challenge. Let me click on the private instance. As I said, you don't have a public IP here. So you have to use the private IP to connect to this instance. To get the private IP and connect using the private IP, you need the SSH command. Since I have already opened the port, view inbound rules, I have already opened SSH port, which is port number 22. I've already opened it. I can connect to this instance from my public instance, but I need the command for that, right? So in that case, You don't want to worry. Click on connect. After clicking the private instance, click on connect. Copy this SSH command. Close it. Okay, let me paste it here. SSH-I. See my key file, EC2 user, which is my username at the rate. This is my private IP. Look at here, private IP of this instance. So I'm using my private IP to connect to my private instance via my public instance. Why I'm doing this? I'm just reiterating. So I can't directly connect to these instances, and to connect to these instances I first logged in into this instance using public IP. Then from here I'm connecting to this instance using my private IP. Since these are all local network within our own network intranet, I can use my private IP. So I'm just using it. Let me copy this command. You have to use sudo. What happened? I think I lost my network. Let me new session. I think we are good. Right. So I'm just using sudo and copying this command. Yes. Sudo SSH-I, your key file, then EC2 user at the rate your private IP. Give enter. Yes. Yeah, we got an error message, permission denied. And if you're wondering why this error message, it's because of this key file. We didn't have this key file in our local system. Then how come we logged in? While logging in, we used putty. So I will just show you the page. While logging into the instance, we used the IP address and we uploaded the file in putty. Whereas when we want to connect to the private instance using the key file, we don't have the key file in our local system. Let me check it. ls. I don't have anything in my current location. This is my location. I don't have any file in my local system. So what I need to do, I need to connect to this instance via some WinSCP or FileZilla kind of tools, and then I have to copy the file from my local system into this Unix system. And how to do this? It's not a big deal. You can go for some softwares like WinSCP. You have to give your host name. This process is exactly similar like what we did in connecting to public instance or via putty. Copy the public IP, give your host name. Username is EC2 user. In advanced, go to advanced authentication. Browse for your private key file, ppk, and OK. Login. Click on yes. Right. So left side is my Windows, right side is my Linux. So you can see the location as well. Mine Windows is in documents, whereas my Linux is in home EC2 user, which is nothing but the same page here. PWT home EC2 user. So if I create a file here, it will be visible there. So it has been created. If you refresh it, you will see sample.txt. And to move this file to Windows system, I can just move it here. See, it has been moved 28th May 7:35, around 7:35 p.m. It has been moved. Similarly, I can move files from Windows to Linux using the same Windows. Let me go back. Desktop. Downloads. Because I have my key file in downloads. Yeah, here is the key file. And see, I'm just pulling my .pem file. So many may be pulling .ppk. Remember, ppk is only for connecting via putty. In all other cases, we'll be using PEM. See here, since I moved it, I can see my PEM file. You can look for ls-ltr as well. It will show you your key file. Now let's try this sudo command. Sudo ssh-i key file and username @ your private IP. Now click on enter. Yes, we are good now. We are into our private instance. So you can confirm with the IP address. Private instance, private IP 100.100.1.118, 100.100.1.118. Now if you try to ping, it will not ping for you, because this instance doesn't have connection to internet gateway, so you will not get internet. But we have already discussed, like, to have our updates and patches, this instance can connect via NAT instance. For that only we have this special instance NAT. Till now we haven't done anything with our NAT instance. Now I'm going to make some changes in NAT instance so that my private instance, which is 100.100.0.32, sorry, 100.100.1.118, is going to get internet via NAT. So what to do for that? Click on NAT instance. NAT has the security group, which is by default is this. Click on your security group of NAT and click on inbound, and you see here NAT is allowing all traffic, but it is having the source as its own ID. See here, own group ID is linked here. We have to do some changes here. In this case, what I'm going to do is I'm going to EC2 instance and I'm going to take the IP address of my private instance. Click on your private instance. You see, what you have to do is you have to take this IP address and just replace it here. But just think of one thing. Our private subnet can have many instances. In our case, it can have 251 instances. Can we go and give each and every IP of that instances in our security group of NAT instance? So that may be time consuming and that may be a tedious task as well. So there should be some other way where I can give a common thing for all these instances getting launched in private subnet, so it is easy for me to maintain something in NAT security group. So instead of giving the instance IP of each and every instance launched in private subnet, what we are going to do is, like, we are going to copy the security group ID. So this private instance is having the security group, which is scenario 2 private security group. Let me go there. This has an ID, right? So copy this. Now I'm going back in NAT instance security group source. I'm clicking on edit, and here I'm going to give that ID, which means any traffic coming from the security group ID of this, just allow all traffic. So I'm just saving it. Once I save it, let me go back. See here, once I save it, it started pinging, because via NAT this instance is getting internet, and in NAT we opened all traffic. Let me click on edit. If I change, instead of all traffic, if I'm changing it to HTTP, save it. Still pinging. Okay, let me refresh it. See now, when I change the NAT instance inbound traffic to HTTP from this security group, so it is even displaying the name scenario 2 private security group. So anything from this, then it is allowing only HTTP traffic and it is not allowing ping. Ping is something called ICMP. So what I'm going to do now is, again I'm going to change it, edit it. Instead of HTTP, I'm going to give ICMP. Save it. Right. See now, it's getting pinged. So I believe you people getting the understanding on these private subnet, public subnet, VPC and all those stuff. So just a brief on all these things. When you go for scenario 2, It is like you have two subnets, one is public, another is private, and public is for instances which can be connected via internet. Private is to protect the instances like databases and stuff. Still, databases need internet connectivity to have its own patches and updates, upgrades and stuff. For those activities, you use a special instance called NAT, which is also in public subnet. And we did the same thing. We edited the security group of NAT instance so that it is getting internet, it is giving internet to all these database instances. And remember, it is not for connectivity, it is using it only for updates and patches. Whatever security group I'm opening here, whatever port I'm opening here, that is what allowed in your private instance. That's it. So we have done with our demo, and now I will show you how to close or delete this VPC scenario 2. So before closing the scenario 2, what you have to do is you have to go to your EC2 instances and you have to terminate all your instances, because before deleting the VPC you have to terminate all your instances. And while terminating, your NAT instance will have an elastic IP. Don't forget to release it, because elastic IP will be charged if you are attaching it to a stopped instance or if it is idle. So when your instance is terminated, your elastic IP will become idle and you will be getting charged. So just remember that. Or if you go to EC2 dashboard also, you will see an elastic IP count here. Click on that and go to this page and then release it. Else you will be charged. Right, now I'm going back to your VPC dashboard. So it is giving me the details of VPC. Click on our VPC, go to actions, delete VPC. It is a similar step what we did in our scenario 1. Now delete it. It will do a cascade delete. It will delete everything, internet gateways, subnets. Yeah, we are done. We are good with this. Yeah, that's it for our demo today. So if you have any questions, post it in the comments and let's meet in the next session. Till then, bye. Take care.